So today's class is going to be on decision tree, but we are not going to apply the same decision trees here. We are going to apply it in a different context. We already know that decision trees can be useful when data is having some outliers or the missing values and so on. So at that time you will use these decision trees and we can solve. We just converted everything into some numerics and then we solved it using the decision tree fit and we got this diagram. Now what we have to do is we have to do the same thing for the ESPN Crick Info data in such a way that I need to predict who will win a match. This is what we are going to predict. So what I'm going to do, I'm going to go into ESPN Crick Info, stats, stats guru. Now I take see here what I'm going to do. I'm going to select any one test ODI or T20I and select ODI now. And in ODI also, I'm not going to select batting, bowling and all. Why? Because I'm going to predict the match result. What will be winning or losing or draw. I'm going to predict that. So I click aggregate or overall. And then here I have several things. So what I need actually is I need match results. So I change the query option here. So far we haven't touched it here actually. I'm going to touch here now. I don't want the overall figures actually. I need the match result. So I click that and I submit. So this is the data what I actually receive. A very small data consisting of who is winner and what is the result. Either one. This is Australia won by 5 wickets with 42 balls remaining, and the matches between Australia and England, and the ground in which they have played is Melbourne. So this is actually the information available. With this information, we can do some sort of decision trees, right? So what we can actually do is, I can take who is the winner, and I can say what is the ground they are actually playing, and I can say who is the host, right? What is host in the sense, if I was playing, if Tamil Nadu and Andhra Pradesh are playing in Tamil Nadu, then we can say that Tamil Nadu is the host. Usually, the people who are the team which is playing in the host ground will get more support. For example, if I come and play in Andhra, then you will be getting more support than me because it is your native, right? So that is the thing. So who is the host? So that you will be getting, and the ground option, right? And this BR is actually says that how many balls is remaining and how many wickets is actually remaining. These things are actually available, right? This is one kind of data set we have. We can actually select whether there are actually n number of data is available in ESPN Quick Info for predicting the match result. So you can take anything, right? I have just took this. I was actually doing this, right? So I thought that directly I can put an attempt on this particular learning scenario with this decision trees in mind, right? Now I ask you 4 questions. I want quick reply. I don't want to ask the same question 2 times and then I get a answer. Quickly, I need an answer, right? In decision tree learning, if I want to do classification, my output variable should be discrete or continuous.
Discrete.
Great.
Discrete.
Now here, what is my output variable? Can you quickly say? Either winner, result, margin, BR, match, ground, date. Everything is there. What is the
Result. You
great
are asked.
result? Yes. Now the cricket, who know cricket can understand what is NR. NR means no result. Maybe due to rain, the match stopped or something. No result is there, right? So we can remove the, if the result is not there, we can remove that, right? So these things are actually available. Now I ask a second question. If you see in the decision tree program of RRR movie, what we have already seen, we have converted everything into numerics. That is, if it is high, satire, low, and all is converted into 0, 1, 2, and state A, P, T, N, Kerala, Karnataka are converted into 0, 1, 2, 3, and so on. We converted everything into some numerical IDs, category to numerical values we converted, and result also is converted to 0 and 1. Same thing I have to do here, right? Now the question what I want to ask to you is, here the host information is not given to you. Here and the match says that Australia versus England, right? Usual way of writing this is the host country is there, right? The host country will be given the first position versus the opponent country. England versus Australia means that England is the host, right? New Zealand versus Pakistan is New Zealand is the host, right? We are seeing that, right? For example, here We have Australia versus England means that Australia is the host, right? Now I need to derive the host information alone here from this particular column. How can I do that? A small pre-processing step only. Just attempt and say how can I do that? Yes, shall I use split? Actually, I want everyone to be unmuted.
Yes, sir. We can use
Yes.
filter.
How? With what basis I have to do the split?
Space, sir.
Space.
Space and we can take the first one, sir. Yeah, I
Yes.
mean, first one.
Yes, exactly what
Filter.
Abhiram says. I also going to do. I want to split with respect to space and take the first one. Everything done in the same. And another thing, what I include with Abhiram's answer is I'm going to append everything into a list and add it to the particular data frame. That is the thing. Additionally, what I do. So that is the thing. So we'll have host, ground, and who is the winner we have. So based on that, we need to do. And it is a very small data set. So you keep this in mind. And if we toss information is also available, it will be a very big advantage. So let us see what will be the task information, right? So let me go into the previous page. Now, task in the sense during match we will be putting a task and say who is going to bat first and who is going to bat second, those things and all, right? So let us take the task. I think task is actually not available here. No, task is not available. The task is usually available in some tasks from the ways it should be available here, but we need to find how it is done. Okay. Now for the initial level, we'll be taking this particular data and we'll be doing some analysis out of that particular data. I'll take that again. I'll put the link in the chat box. You take that. Go to the chat box. Right. So this is the link what we need to scrap. So I add one more thing. We need not scrap it one more time because we already scrapped the ESPN Quick Info. If a website is scrapped once, whatever data in whatever means I need to scrap, I can use the same code. So no need to use the scrapping code again. Right. The same thing is going to be used again. Right. So what I will do, I'll take the data recently we used for k nearest neighbors. So that data for scrapping I'll take and I'll say you what is the difference we need to do with that particular data. Let me take it. I paste the data. This is actually the code what we actually used for ESPN bowl stats. Recently we did for KN and K nearest neighbor classification by using this bowler stats. So we do this. So the exactly the same code you can also take, right? Now I need to change the fields. I have some different fields. I don't want actually these fields. So what is the field actually present here? The fields actually present here are the winner, result, margin, PR, match, ground, and start date. If you see clearly in the inspect code of this, you can actually see that there is a row in between this and there is a row over here, this particular thing. So we can put an empty over there. So what are the things I'll repeat? I just take winner, result, margin. So I just substitute here winner. I just comment over here. I'll get winner, result, margin, PR, and over here match, ground, and date. Match, ground, and date. I delete all the remaining things. And this final is an empty thing for this triangle hyperlink. For this triangle hyperlink, there is a column name over here, so I take that also. And if you see the inspect over here, there is an empty row present between dr and match, so I include that also. So I have an empty row here, right? So this is the thing over it, right? Now I come to here, let me change the file name to something good, ESPN ODI match results. I have the code like that with the ESPN ODI match code results. Now I need to change the link. Now I have put the link in our chat box. If you see, this is the link over here, and for this link we can actually do the thing, right? Now if you see the link, you copy everything and then you paste over here. This is the URL. We have split the URL into three parts. If you put URL one is equal to, you put the entire thing. You keep only up to the class, and here comes the page. Now you take these things, template, result, everything you actually take it, right? You clip up to the class, and all other things you actually take it out. Class 2 represent ODA. You take that, and this is the URL one. You don't want this URL one, right? Then the remaining from template from the end, you paste it over here. That's the thing we are going to do. We paste it over here. So that is the only difference. You change the field names, then you change the file name, and you change the link accordingly. Right? You do that, then that are the changes which what we have to do. And with respect to number of pages we are going to scrap, let us have some 20 pages. And with these 20 pages, let us scrap the particular data. Right? So we have this particular item specific. Right? So I want everyone to do this scrapping first and let me know in the chat box of whether you have completed or not. I repeat again, what are the changes to be done? The changes to be done are the field over here, the 9 fields you have to enter. There are 2 empty fields also, you take note of that. And you change the file name and you change the links of URL1 and URL3. We are actually having URL as 3 parts for to make it scrappable across multiple pages. So you do that. Once you have done, you put it in the chat box that yes, completed scrapping. You put the tag like completed scrapping. Have some pre-browsing activities to be done in this particular thing. So what is the first thing what I'm going to do is, I'm going to read the particular data. If you see in the decision trees, this is the decision tree data what we have. We in the second step, we actually read the data set. So I read it. So I did as df is equal to pandas. Oh, I need to import pandas and those so much packages are actually need to be imported. So I first import the packages. Import pandas as PD. Next, I'll read the data set. For reading the data set, again, df is equal to pd dot read csv of. Can get suggestions here. So I can take over here. Let's have to run this. Let me run this. URL string letters. I didn't put a double quotes here. It is working. 2, 3, 4, up to 19 pages it will be scrapping. Now I go here and I look into the data what I need. ESPN math results. And I just put a df.head of to see me what is the data set actually. Yes, I have winner result margin df. If you see here an empty column is named, that is we named it as unnamed, unnamed, right? We can first drop those unnamed data. What I do is df is equal to df dot drop off. Drop in the sense I will drop that particular column. So df dot drop off, I just copy this particular. I didn't give any name to it, so it is unnamed 4. Drop off unnamed 4. We put it in the single quotes. And we can specify the axis. If we put axis is equal to 0, then it is row deletion. If we put axis is equal to 1, it means column deletion. So for example, if I put axis equal to 0, it means that unnamed 4 is actually some ID over here and that ID will be deleted. If I put axis is equal to 1, I'm going to do a column deletion. So this column will be deleted. Next, I can delete this final column also. df is equal to df dot drop off. This eighth unnamed 8 also I can delete. Axis, that is axis is equal to axis is used to specify whether it is a row or a column. If you put axis equal to 0, it is row, and if you put axis equal to 1, it is column. Right now, I run this. So what will happen is I got the columns deleted. I got this unnamed 4 and unnamed 8 deleted. Right. So that is what happened here. Right. So we got the result. Right. If needed, we can also drop the NA values. So if or before doing that NA dropping, let us do some sort of scrutinizing, and then you can do. Let us open this ESPN ODI match results and see how the data actually is. If you see the data over here, I have something like NR. In the result column, I have something like NR. So I need to remove those NR values. And if this NR is present, I cannot predict anything, because if output variable should be either 0 or 1, or if it is a draw like thing, I can use. So I don't have the output variable ready. So I need to remove this NR. I have to do that. So what I can do, I'll do a pre-processing for. I do the pre-processing. So before I go to the next step, let me you can take some screenshot over this particular cell. Yes, if you have done with this, or you have taken. So next still what I'm doing is I'm going to pre-process uh, the result column. So in result column, what I do, I just take some res. Say res is going to be some result or some result variable. So df of, I take the result. So what is the exact spelling I take? This is the thing. The df is going to be the result. I can take this and I put on the single quotes. So now I need to do some actions on this result in such a way that if results are going to be there with NR values, there is no result values, I need to drop the entire data for entire row. If that is there, I can drop the entire row, because that is not going to give me any good results. So I can drop the entire row. So what I can actually do is just I can understand what are the data that is having the result. So I took that is actually present in this df of result that I store in res. So instead now what I can do in this df of result, which is going to be equivalent to something like n slash r. That is no result. This is the value actually present here. If this is equal to that, and if any particular string that, so this is actually now this become a boolean function, and for this boolean it will be returning either true or false. So what I do, I take df of the entire boolean value. So I take the entire boolean value. So if it is true, the entire row will be selected, and I select the particular index. So I repeat again, df of result takes this entire result column, and this result column, which row is having nr, that I will first select. If it is nr, then it will be true, and df of true will find that particular row. And for this particular row, what is the index? If you have something like bold here, no, this is index. I select the index, and that index will be placed something like in res, or I can say like nr. I can keep it like nr. That is no result. Now what I will do, I just say df dot drop off nr. So where in place I say in place equal to true. Why? Because you drop, and the result should be placed in df itself. You drop it, and the result should be placed in df itself. Right? So I run this. Now if run and see the df, will be not getting any nr values. All the nr values are now dropped. Right? So this is actually the case over here. I explain this one more time. What I do here is I take the result column. In this result column, if I find anything as not result, then what I do is I take that particular row and I find the index and I delete the entire row. So if I want to delete, I just put drop of that particular nr value. Right? This is the thing what I do. Right? This is actually pre-process the result column. Right? Is it fine? Because doing decision tree is very simple. Just we need to do a fit. But pre-processing matters some more. Here we need more pre-processing. Right? Is it okay? Fine. Now I go to the next step. I do a pre-processing one by one so that we can understand what are the pre-processing being done. Next, what I'm going to do is I'm going to pre-process. What I'm going to pre-process? I'm going to pre-process the particular match record and the ground stats. So I take the ground. So we know that this Melbourne, Manchester, Lords are actually different ground names in that particular arena. So if you see the decision trees, I have like AP, Tamil Nadu, Kerala, Karnataka, everything in the decision trees. I converted everything into 0, 1, 2, or 3 like that I converted. So I need to convert this. You can have several, there is several ways to convert it. But if you want to understand clearly, what I'm going to do is I'm going to use the same map. You can also use dummies or you can also use categorical to numerical conversion function and you can do that. So actually, if you want to understand keenly on how it is being changed, you can use this. So what I'm going to do is I'm going to take the particular ground values and I first what I store it in a DF, right? I just pay ground is equal to DF of this particular ground. I take this ground. Now I want to convert Melbourne to 0, Manchester to 1, Lord to 2. Like that, I need to convert them into some numeric discrete values. I need to convert them. So that is what I'm going to do. And there are several repeated values also. So what I do, df of ground dot unique of. So this unique function will actually give me only the on each of ground only one time. It will not be duplicated. So first I'll take that. Next, now I create a dictionary. I created the empty dictionary, GRD. And for this empty dictionary, what I'll do, my unique values are present in ground. And I say I want to assign them 0, 1, 2, 3 like that. So I press here ID equal to 0 for I in ground. What I do is for each of that I can for example I will be Manchester, this Lord, Mumbai, this Rawalpindi, Faisal, everything will be coming. So what I do is GRD of I. So it is a dictionary. So it is a key value pair. So key is actually the city name, sorry, the ground name, and I value I can assign. So I have ID here, ID, and then for each incrementation, I increment that ID to +1. So now what will happen for I in ground? So let us first, I'll first let you understand how that ground will actually look. You see here the unique grounds. These are the unique grounds: Melbourne, Manchester, Lords, Birmingham, Christchurch, Swansea, Leeds, Oval. Many grounds are actually present. I want to convert them into zeros, one, 2, 3 like that. So what I will do, I'll assign this. Now for each ground, say for example, Melbourne will come first. Melbourne will be assigned ID 0. Next, I increment ID to 1. So Manchester will be 1. Lords will be 2. Birmingham will be 3. Christchurch will be 4, and so on. Like that, I'm assigning something. So once this assignment is completed, I can map that particular numerical discrete values to the original data frame. So I go to the df of ground. This is a data frame. Df of ground is equal to df of ground dot map of this particular GRD, because GRD is having the particular numerical value for that. So I do that particular calculation and then I just print df and see how the result actually changed. If you see here, the ground names are actually now changed into 0, 1, 2, 3 like that. Right? Means that the ground values are now converted from categorical values to numerical discrete values. So by using this map function, right? Yes, I am making this particular pre-processing clear. Very normal pre-processing, no much machine learning involved. Normal mathematical pre-processing I'm doing, right? Shall I proceed? So the pre-processing of match, like Abhinam said, I want to split it into different ways by using the space delimiter, and I take the first one, that is host. I want to do that. That is the next pre-processing I want to do, right? Because I need to split that. Right now, same procedure. I say like I can say mat is equal to df of this particular word I take match. I put it in the single. So what I need to do is I need to split them in such a way that I need to get Australia from this Australia space B space England. I need to get Australia alone. So what I can do is I need to split it separately. So I take like host is equal to, or I want to do it for everything. So for I in match, for I in mat, host is equal to I dot split of, with respect to what delimiter I need to split, with
Space.
space. Great. With respect to space, I split. And if I say host is equal to I dot split, so with that I have to take the entire split, or which particular thing is second, zeroth one or first one or second one?
Zero.
Because I will
Zero,
take,
zero.
yes, I will
Zero.
take the zeroth one. Yes, great. I'll take the zeroth one. That will give me the right answer. So I'll take that as zero. One small addition I do, instead of substituting it in the host, you can also have something like host as a list. Host is equal to something, an empty list, and host dot append
And
of I dot split. Yes, you are great. Yes, I just append it. So everything is actually appended inside a name called as host. Now let us print and see what is in the host. Yes, I have Australia, India, West. Why it is being, oh, West Indies? Oh, that is a problem. Okay. So let me split because you understand, right? If some name themes will have names with spaces. West space Indies, South space Africa. So we cannot split with space. Shall we split using V? That will be better, right? But V also cannot be possible. We can split by using space V space. Am I right? That will be better, right? By using space V space.
Yes,
But
sir.
yes, I'll be splitting with respect. So already one space is there. V space. I need to split like this. Okay. That is we getting Australia, India, West Indies, India, South Africa. So we are getting that. Now what I will do? Now we have to do one thing, that we have removed that thing, the data frame, and NR values, everything, and we converted this ground also to zeros and ones. Let us first append this host also to our data frame. So I'll give the name like df is equal to, I'll give host, capital H host, df host is equal to host. Now let me print and see the df. So my new data frame will have something like host. Host information is also available, right? Yes, super. I have the host information also available. Now what we have to do is we need to compare winner and host and calculate the result. Now you have to finish this. What is the next step I'm saying? What is the next step is I need to compare host and winner. If Australia is a host and Australia is the winner, I should say what? Result is 1. If England is the host and England is the winner, I say result is 1. If England is host and Australia, the opponent, is the win, I should say result equal to 0. So the result should be with respect to the host. If Australia come to India and Australia win the match, it is not like Australia win the match. It means that India lost the match. So result should be 0. Right? Am I making it clear or am I confusing?
clear, sir.
Yes. So in this particular thing, India is host, and when the West Indies won the match, so what should be in result?
Zero.
0. So
India
that is
lost.
what. Yes. So India lost. So we need to put it 0. So that is the next thing we are going to do. So we need to compare host and winner, and we need to find the result. Right? Yes. That is the third pre-processing. So that is we I put here this pre-process match column to find host. Right? And I'll go to the next thing, that is comparing the host and winner to find the result, right? So what I will do, compare host and winner to find result, to pre-process result or to update result, right? So what I'll do for I in, so first I'll take the df. Df is equal to df of winner or I should take winner. Uh, Winner is equal to df of winner, or you can also take like this is zeroth column and this is first column. Df of 0 I can take for I in df, or let me do like normal itself. Winner is equal to df of winner, host is equal to df of host. For I in range of len of winner, if winner of I is equal to host of I, I'll keep something like match result, because I have already one column that is result, so I should keep something different. I keep match result. Match result as a list. Match result is a list. Match result dot append of, if both are equal means one. Append of one. Else match result dot append of 0. So this is the case what we have. Let me print and see what is match result. We had an error. Okay, this data frame is not accessing it. You need to access it like an array, I hope. Inner of I. Winner of 0 is Australia. First is equal to D of first. For I in range of then of winner, if or I can do like for I comma j in winner comma host, if I is equal to j, then I can do uh, match result is equal to a list, empty list, match result dot append of 1. Else I say match result dot append of 0. Let me try and execute this. For I comma j in winner comma host, uh, let me find and crack this.
For I comma j, sir.
For I comma j only I gave initially. For I comma j in winner comma host only I gave. See this error.
Hmm.
For I comma j in winner comma host, if I equals j, it is actually I think it is treating that winner as some array.
Sir, keep that in tuples, sir, winner comma host.
Come again.
keep winner comma host in tuples, sir. I mean in brackets. Once try and
Okay,
try.
tuples.
Keep zip in front of tuple, sir. Zip is function.
Okay, it's done. Thanks. It's coming. I'm getting it. Now I can actually post this match result to df of match result is equal to match result. Yes, I got the match results also ready. Only final thing is want to convert this Australia, England, everything to some zeros and one values. That is very simple. Why? Because we have already converted this ground into zeros and ones or something. Same procedure we have to use again, right? So you finish this and let me know. This comparing the host and winner to update the match result. Okay, let us proceed to the final thing to prepare the data set. That is want to convert this host and winner to discrete items. I have already done that for ground. So in the above, if I go and see, for ground, I'm having this pre-processing. That is pre-processing the ground, pre-process the ground column. That is categorical to numerical discrete. I do that conversion. I take the same thing. I don't. We can create a function also for this and do. Otherwise, we copy and do here. We're not going to do any computational task, so calling a function and do. You want to create a function of that and do. Otherwise, you just copy it and change it to. First one is what I'm going to do is I'm going to convert it into winner. Winner is equal to df of winner. Note it print. I say this as win. For I in winner, win of I dot and winner here also. I put it. These are the changes. Just I want to append it and take the unique values, append it, and that's it. Similarly, do it for host. I put it first. Ht as host. Ht of I. HST. These are the changes. Let me run that and see, and I'll give you time for you also to do that. Yes, now winner is converted into zeros and ones. And I run this. Here, HST. DF is equal to HST that unique. What happened? Object is not callable. HOST is what I have kept it. DF of host dot unique. DF of host is equal to DF of host dot map. HT, sorry, HT. Yes, now host is also converted into zeros and ones, right? So you do this, that's all the pre-processing done. Now we can just use call the decision trees and just say fit. That's it. We'll end the program. So each time when you take any real-time data set, more time will be spent on pre-processing. Can either use the pre-processing packages directly available, but that will not be useful when we want to do pre-processing in our own style. For example, we developed something like host from the match column. We compare the host and winner and created a match result column separately and so on. So we can actually do our own things by doing these kind of steps, right? Everything is done. Let me select my input as well as the output column. right? I'll be selecting my input and output. If you want to take screenshot of this poster, you just take screenshot. And anyone please unmute and say to proceed. So I'll proceed to the next file as well. We'll finish up this entries. Anyone please unmute and say to proceed. I'll proceed.
Proceeds.
Yes, thank you. So I go to the decision trees. Now everything is actually all the pre-processing activities done. So I need these packages for decision trees. sklearn from sklearn import tree. I need PyDot plus. I need decision tree classifier, matplotlib, and I want to save that image also. So I take these all packages from here. Already I have imported pandas as PD. Other things I take from here and go to this and I import my packages first. I get all the packages ready. Then I can take and I do the decision tree fitting over here. If you come over here, I need to fix what are my inputs and what are my outputs. So I come here. So I know what is my output. My output is going to be maths result, and input are going to be my first one is I need to have some input like this ground is going to be input, host is going to be my input, winner is going to be my input. So these things I can actually have. So this host and winner anyone can be used because maths result will actually say that. Else we can actually do some pre-processing with respect to this particular runs or wickets. That is going to be the thing. But this runs or wickets is not actually identical. It may be different with respect to match packs. So let us try to do a very small decision tree with only two attributes. Say for example ground and host. Let me also extend the features once we go further. As for now, let us have only two features. Features is equal to, we're going to have host and ground. That is going to be my x. My x value is going to be that. And once the x value is fixed, my y value is going to be my mass result. Right? BF of features. And y is going to be the BF of mass result. Right? So we get the input and output ready. So now what we can actually do is we can actually go and just fit our decision trees. That is the final step. We take the decision tree model, we fit it. That's entirely the same code you take. You copy over here and you find the result. It is actually a very simple model. We have taken only two features. For decision trees, we can actually give more. But just we take two for an exercise kind of thing. I change it to decision tree, comma, mat result. Right? Let me run this. Feature spelling is wrong. Yes, I get a very big feature. Let me go and see the picture very clearly. It's a very big decision tree I'm having. What a big decision tree I actually have. So this is the thing. Host less than or equal to 10.5, right? So we have to see what are the countries having less than 10.5 as host. So if they are the host, they have the high possibility to win it, right? So see the values. They're actually we tend to see here that both the positive and negative samples are somewhat more closer. So there is no much impurity. Now if it is even though less than 10.5, if it is less than or equal to 6.5, they have even more probability to win, and less than 2.5 next. And if there is less than 2.5, there is another classification with respect to ground also. And in that ground, we have a less than 4.5 again. A very good classification result you can actually obtain over here. Right? If I give some new values to this, you can do something better also. A very big decision tree, doing it better. Yes, fine. It is actually doing with the Guinea value. Right? Either using entropy value or either using Guinea, I can find the impurity or the purity of split. So this is the thing, right? So this is the decision tree what we have assigned by using that particular ESPN match result data set. Fine, right? Yes. Let me go into the data again. Like again, the side in the image, it is somewhat very
Can
clear.
you share the codes last?
Yes, I'll show that. This is the code. This is the cell or the before cell?
That cell means last one.
Yes, yes, yes. We can also do one thing. We can split the data into training and testing, and we can find what is the accuracy of testing also. That also we can actually do. That you can have that an exercise. We'll split the data into training and testing sets. If we split the data into training and testing, and we can also find the accuracy level also. Right? Let me show the code also to someone. In which line, if you want, I want to show the code, I will show it. Right? So, Akshit, have you tried with the training and testing? Akshit.
Doing that thing only, sir.
Okay. Why? Because the same problem statement we are going to use and we are going to do with Bayesian classifier as well as an SVM classifier. So we need to compare the accuracy with respect to different classifiers. That's it.
Sir, 54% coming, sir, accuracy.
Very less. Okay. 54% is very less.
54 and precision 51, recall
Recall.
37. 37.
Okay. Recall.
For
Okay. But
zeros 37 and for loss 37, for wins 70 recall, and
okay.
precision is 57 per win, sir. One
Okay. Precision is actually low. Recall acceptable, but precision very low.
recall false positive
Accuracy.
accuracy 54 54 0.5489
Okay. Very
54%,
less.
sir.
Very less.
Okay, shall we try for scaling down the features? We can.
But there is not only two features we have to take. That is also one of the drawback. We have to take multiple features also.
Yes, sir. If we try with the two or more two features means we can
Yes,
get
surely.
accuracy high.
Yes, exactly.
So, features, if features high also problem, low also problem.
Others other than Yugandhar, you can even try it with accuracy, please state your accuracy level. Yugandhar, you put your accuracy level in the chat box.
Yeah, okay, sir. Done, sir.
Shit, Archirudi, Akshat, Pavani.
Or we can add another attribute, sir. Team. After splitting with V, we can add the second team as another attribute.
Yes, opponent. Okay, great. Opponent can also add that. Let me do that. Very simple. You can have like, but I want the split. I could do then the split cell where it is splitted. Okay. Resist is spread over this area. First, opponent is equal to a list. Opponent dot append of k, k of 1. Pf of opponent is equal to opponent. This now opponent is ready. Want to convert opponent into discrete items. Opponent oh, opponent and oh, let's get this. Opponent is ready. And here also I'll take return the opponent junction. Any NaN values are there. So that is actually the problem. We'll have something like opponent here. I just change the name. DF of opponents is going to be there here. These opponents are ready. And I take exactly the same name here. I take exactly the same name here. I come to the bottom. This here. So here this is HST is the problem. It is open. We can actually drop this actually, but we don't. No, it's not missing. I just opponents. Okay. I think the opponent's speed is actually not fully changed. It's actually changed, but it's running in randomly. I'm running it, so maybe the problem I hope. That's why because it is security running it in random. Because here it is updated. The reason for not updating there may be randomly running it, right? Fields in between not running.
What it is showing, sir, down?
Come again? It is actually saying Australia is a string and cannot be converted into float.
For opponent.
Uh, but opponent is actually opponent is empty in NA and I need to remove this. Opponents is what I actually have it. I have print. Let me print and see the opponents also. Because I have everything as an integer data type only. PF dot drop of opponent this is equal to 1. Opponent is not 1. PS is equal. Place is equal to 2. I need to put. Let's see. Host is actually not changed. That is actually the problem. Not because of opponent, it is because of host. Yes, it is working. Now you check this the way for doing including the opponents also and try. It is working. I'm getting a new decision tree with enlarged decision tree is obtained from this operand data also. Now I check it. With training and testing values.
60% accuracy.
Great, 60%. It is increasing with opponent also. Uh, any other data? Most important data is TAS. TAS is actually most important data, but we didn't get TAS here. If possible, we need to get the task data from some other data set, combine it here, and then we have to do. Pujita, you also put your thing over here with the features what you have taken, the chat box.
Okay, sir.
Akshit, what's yours, Akshit?
Previously 0.5, sir. Now I am computing still.
Okay.
Sir, what is BR?
What is
In that data set, sir, BR it is
balls?
there, right?
Balls remaining. Balls remaining in the sense, if I win the match in 45 overs
Got it, sir.
itself,
Got it.
30. Yes, 30 ball remaining. We can also use that, but if I want to use that, we need to do more pre-processing. Why? Because some teams will not will be batting first, some team will be batting second. So those things also only when task is available we can use this. But we can actually extract the task from this also, right? Yes. With your point, I got this. By seeing this wickets or runs, if it is wickets, then it means that it is actually bowling second, batting second. If it is runs, na, it is batting first. Like that, we can actually take batting first, batting second. More information can be obtained. So that is what beyond using the machine learning algorithm, that is easy, but using those data efficiently is actually the tougher job. We can play with it the right maturity. We can it'll be useful for taking the batting and bowling also, right?
Which one, sir?
By wickets and runs is there, na? If I take wickets and say that it is that also can be useful, right?
Yes, sir.
But more pre-processing need to be done.